for coming to the keynote. It's my pleasure to introduce tonight's keynote speaker, Professor Dennis Shelden. I know Dennis because of his leadership on many different levels. During my time at MIT, he was a professor at MIT as well. So I've learned about the work that he's doing there. But more importantly, the work that he's leading now is a leadership of the Digital Building Lab, which was founded by Professor Chuck Eastman, who's with us in the audience. And the DBL is doing two very exciting things, really. One is the approach to research that has to do with work with advanced doctoral students and MS students that influence academia and scholarship in many different ways. But the unique aspect about the DBL is a very strong connection to industry, where there are partners both on a local and regional and national level and international, working on influencing industry aspects when it comes to what is produced in the lab, when it comes to digital technologies, and how it can translate into industry frameworks and workflows that becomes influential and actually moving data in directions that become very, very exciting. So that's the influence of the DBL, with a background of 3 degrees from MIT and leading academia both at MIT and Georgia Tech. The expectations are very high, so I'm not afraid to say that this is going to be fantastic. And it is my pleasure to welcome the first keynote to SimAUD, Professor Dennis Shelden.
Thank you. Good, thank you, Tara. And I was going to lowball it because this is a really sort of frighteningly sharp group of people. So, and the work that I show, I was just catching a couple of the presentations before, and I think some of this is in line with what folks are doing here and what I saw, and some probably pales in comparison to the work that you guys are doing. But I did want to, so first of all, thank Tarek for having me speak here. Thank you all for coming to Georgia Tech. It's great to have this organization at our campus. And what I wanted to do, because again, I don't think I can outsmart you guys in terms of simulation or even necessarily the digital, is talk about some of the things that I think are interesting going on now. I think what Tarek mentioned in terms of the relationship between the Digital Building Lab and industry and evolutions of practice are really the things that are have been most profoundly interesting to me. And the connection between advanced research and emerging capabilities and the profound shifts that are going on in the building industry are the most exciting things for me. They've always been. And so I think that's really the context of what I wanted to spend my time talking about today. These are two buzzwords that I've been using quite a bit. I don't think the idea of cyber-physical systems needs a big introduction. I think people are sort of the vernaculars there. Open data platforms is really the heritage of what the Digital Building Lab has inherited from Professor Eastman. So those are two really kind of critical things that are impacting the possibilities of the profession right now and the possibilities for the future of the profession. So I wanted to talk about those. And again, I am not really an expert in simulation per se, but I think since this is SimAUD, I'd like to sort of make that connection between simulation and evolutions of technology and practice going on in the field today. And these are the three themes that I want to kind of come back to. One is kind of a fascinating possibility around the convergence of physical and digital things. There's lots of stuff going on in the sensor space, in the virtual reality space, mixed reality, all that kind of stuff. And I think a lot of my background has been around sort of that translation between digital and physical, but I think it's sort of a really interesting kind of possibility for the future. Connected systems, I think maybe that I can spend a little bit more time, and probably less familiar for you guys is this question about kind of changes to practice. But these three themes are all related, and that's really what I want to talk about, is that connection between platforms for changing the industry, this convergence of digital and physical, and the new opportunities to create, and then what new types of organizations are doing to meet those opportunities. So I'm going to kind of take this structure. First of all, it's worth spending a little bit on time on my biography and where I was before I came here. Mostly I want to use this as a platform for talking about what the exciting stuff that's going on at Georgia Tech around the Digital Building Lab, but there's a whole ecosystem around us, and I want to mention some of the other great work that's going on, and then finally these ideas of the future of the industry and opportunities kind of springing from, and what we're trying to do to address those. So, so just really quickly, my biography, for those that you don't know, I've kind of had a foot in academia and professional practice my entire career. I've worked at the intersection of architecture, building engineering, and design computing for all that time. Most of the last 20 years have been more on the practice side. So I've been associated with Frank Gehry's practice, first as the director of technology and then as the CTO of a technology spinoff. And really for the last 3 years I've been mostly more on the academic side, focused on the kind of the constructs of academia and research, but I still try to make those connections. So really my background is on both sides. And really early on, I just want to sort of say that, my original interest after I went to school as an architect was this idea of connected, integrated practice and the possibilities of using digital technology as a way of bridging across the domains and the silos of the building industry. So very quickly after I graduated, I actually wound up working as an engineer for Arup and Partners, as they were called at the time. Now they're just Arup, and really early stuff at the simulation level using computational fluid dynamics for airflow, studies of this is the Richard Meyer Phoenix Courthouse, so passive environmental cooling strategies using digital modeling as a kind of foundation of understanding that, and then also, kind of classic finite element analysis on an award-winning bridge that I did with Guy Nordenson, who now has his own practice in New York. And then I got started with some interesting technology companies quite early. So this is the work of Consultants Computation Bureau, which is a kind of a technology company in San Francisco that had a relationship to DO2, the development of DO2, which is now, that was the precursor to Energy Plus. But very early, we were trying to develop real-time building energy system optimization, connecting simulation, optimization, running DO2 through multiple cycles in order to do real-time connection to the building control systems in order to optimize performance. It didn't work for some of the most bizarre reasons. Basically, we couldn't get the Sun Spark stations that were doing the optimization to connect to the PCs over Novell networks. If anybody ever heard of that, was before the internets. So it really kind of failed spectacularly in some really interesting and kind of pathetic ways. But along the way, I think there were some really interesting experiments. One was this kind of visual interface using Smalltalk, which was a kind of some of the innovation that came out of Xerox PARC around the kind of the genesis of first the Macintosh and then Windows, and then just using things like AutoCAD to map data that was coming from the simulation. So very early, I was very interested in sort of this real-time connectivity, simulation, representation, all that kind of stuff. I went back to MIT as a master's student and got very involved with the dean at the time, a gentleman most of you probably have heard of, Bill Mitchell, who was very interested in distance collaboration. Video conferencing was really hot for some reason at that time. But the web was just becoming interesting as sort of a connective approach to design, to presentation. I got very interested in this idea of sort of collaborative data systems, so how you could take virtual objects, drawings, data, and all that, and kind of connect it into some of these information management platforms. And it was through that relationship and trucking out to Los Angeles to set up some distance collaboration with Frank Gehry's office that I got introduced to Frank's technical partner, Jim Glimpf, and wound up completing my PhD with them, going non-resident to work in that practice. The problems that were kind of under pursuit at that time, I think have profoundly influenced my view of what it means to be digital, what the relationship between physical and simulation is, the role of materials in representation, and really some of the kind of, I think, challenge some of the underlying determinacy and assumptions of determinacy that maybe we still have around simulation. The idea that there is some sort of, defined thing, and that we can capture its behavior in increasingly precise ways and play it back in ways that are meaningful. I think there's a challenge to that whole supposition that is very sort of postmodern in terms of our understanding, our relationship to representation and empiricism. At any rate, I think those questions are really underlying a lot of what was interesting about that work at that time. Specifically, what even are these things? How do you describe them? And how do you capture their behavior in ways that can serve as a conduit from small physical things to large operations on physical stuff with digital in the middle of it? So a lot of the work at that time was focused on capturing a specific set of material suppositions around low curvature deformation surfaces, so-called paper surfaces, as we would call them. You probably know them now as more things like developable surfaces, reduced curvature systems, but also there's really is a whole spectrum of possible simulations and representations of those material behaviors. And what I found fascinating about that problem at the time was that these different representations or simulations were discrete approaches to representing the same physical phenomena, and that the selection of an algorithm would generate a number of features that could be used as an approach to constructability, and that would essentially guide you to different sort of constructible systems. So, I think there's some of our esteemed shapegrammarists in the room that think about the sort of the language of representation and design, and I think that's really sort of a profound conditioning of design in terms of, and maybe it's obvious at this point, but the languages that we use for representation, for simulation, these drive us into different sort of views of the world that ultimately have a mapping to different ways of constructing things in the world. And that's a long way of saying be careful what algorithm you choose, because it will drive you, and it will drive you as much as you drive it. And then there was the whole sort of development of this approach to 3D representation as a construct for professional communications, for exchange among stakeholders, all that kind of stuff. And what I find really fascinating about that early work was just, because we didn't have a lot of computing firepower, just how judiciously the data was used as a way of sort of focusing a conversation, right? So we literally had to, and I think we still are, constructing the conventions of project delivery around representation. And again, when we didn't have a lot of cycles to throw at things, you had to be very judicious, but it also was a way of being very precise about what you meant and what you didn't mean. Those representations, of course, as computing firepower got increasingly available, grew richer and richer. But I think that basic question about how does representation even play in the process of design exchange, and that it's not obvious what it is that we're communicating and why we do it and how we represent it is still sort of central to this idea about data platforms and exchange that I'll talk about in a little bit. So I wound up doing my PhD on that subject, specifically around surface representation and constructability. Both kind of defined specifically narrowly around algorithms and their role in communication, but also more generally about this idea about the digital physical representation in project delivery. And then later that year, we decided to start a spin-off company called Gary Technologies that had the intent of taking those emerging technologies and also the practices around that to the market. And I think there are two interesting kind of declarations in that business plan that sort of persisted. And the first one is this idea of the integrated digital master model that creates a communication platform that can connect all of the stakeholders. I think now we know, and practice has evolved, so that idea of a single master model isn't really what happened. And in some ways, it was a lot easier when we had that ability, when we can just say everybody has to use the same software. All of those questions about exchange and loss of information and ambiguity about different representations, we didn't have those problems, and those are really kind of central to the problems we have around building information exchange. But that was at least the premise. And the second one I think is more interesting in retrospect, which is the relationship, the possibility of relationship between a design practice and a technology company, and the different ecosystems that those and opportunities that are afforded to those different types of businesses, and the ways that they can collaborate to create change in a market, and the ways that those different organizations, the ways those models of practice vary, and how those things can combine. So that was really sort of the genesis of Gary Technologies. Over the next 10 years, we grew to 130 people in 10 offices. That really kind of hit its zenith around 2008 for some of you that were around then. At that time, people were just building the craziest stuff they could think of. And sort of paradoxically, it seemed at one point that everything was being built in Dubai and nothing was being built anywhere else, and that seemed odd. And then, the market kind of collapsed after that. But suffice to say that we had a really good sort of run at that time, and it kept going for quite a while after that, both as sort of digital consultants and process consultants around technology, and also developing software. So we built two really interesting pieces of technology. One was a product called Digital Project, which was a kind of a redevelopment of the CATIA engine. I don't know how many of you heard of CATIA at this point? Okay, how many use CATIA, the new V6 stuff? It sort of is having a resurgence, right? And we used to teach it at MIT as well. But that, I think, was a really interesting approach to parametrics at the time. A lot of what we did with that, you can now do with Grasshopper and Dynamo, and it's a lot easier. But it had an approach to kind of design to fabrication around sort of parametric solid features that I think was really interesting, and it could scale. And the second technology that happened quite a bit later was something that was originally called GTX. Then the marketing people got a hold of it and called it G-Team, and now it's called Trimble Connect, which is, Trimble bought the technology and actually most of the company, but it was the idea of sort of wrapping building information modeling in kind of some of the emerging social graphs, social constructs that were emerging out of social media, and the idea that you could come up with collaboration systems that were very different than the kind of hierarchical structures that we know from project contracting, and that building data had a kind of a central component to that. And this was a really interesting kind of seminal project that I think kind of combined both of those, which was a 3-year project that we had around the World Trade Center in New York, working for an organization called the Lower Manhattan Construction Command Center, where we were aggregating all of the 3D models, 2D drawings, and schedules through this approach, this kind of structured hierarchical view of project information. It turned out using Digital Project, we could scale this to a city scale. But we also had a really interesting gentleman named Victor Cato, who I think is now doing stuff in the stock market around simulation as well. But taking the data, putting it on the cloud and exposing it to the broad New York City community. And I think this really was a very interesting idea about taking building data and using the power of distributed computing in the cloud as a way of scaling it. So for us, that was a really important moment. And just to kind of talk about some of the takeaway points from that era, the first is this very intimate kind of cyclical relationship between physical and digital. And I think this idea now is ubiquitous, certainly on the second half of that pipeline. The idea of starting with physical assets as design artifacts and processing them through the filter of digital representation, I think, is something that is less apparent and really profound. There's something different about starting with the sort of indeterminacy of the physical world, the possibilities and the wrestling of trying to capture that using, again, sort of selections of algorithms, where those algorithms condition provide implicitly languages that condition the representation, and then playing that back through. So just kind of some interesting ideas around that. One is this idea that I thought was interesting, where the digital representation becomes kind of a bandwidth filter on information in the world. So these things are very messy. They're sort of deliberately sort of indeterminate, and we don't really have good ways of representing that indeterminacy through digital techniques. You might say, well, now we can just point at clouds, scan those, and that's true, so we can just sort of throw more data at these things. But I think that question about representation, lossiness, compression, all those kind of things is really interesting as it pertains to the relationship between the physical and the digital. The second really interesting thing for me has been that idea of representing buildings as organizations of parametric objects and their encapsulation of behavior. So the systems that we used at the time, which you can sort of do with Grasshopper now, although I think it's really still very difficult, is creating intelligent objects which can kind of plug and play into a context, into this framework, but they can also carry a bunch of other sort of behavior besides just their geometric resolution. So they can solve themselves, they can look at statistical relationships to their friends, they can produce their own documentation, and this idea of kind of an object-oriented approach to the development of building systems, both through their digital representation, but also in general, is one of the things that sort of stayed with me. Another sort of possibility or interest, I think, is this idea about kind of the morphology and the structure of systems. And those systems, I think it's not too surprising that building systems have a morphology of assemblies of parts and wholes, and that those assemblies have a topology. What's a little bit less apparent is that that topological structure can carry from the physical objects to the information systems to the processes of delivery. So every one of those kind of constructs has a morphology, a topology, if you will, and it sort of became apparent to me, somewhere in this, in the process of working with Gary Technologies, that really what we were doing was defining those organizations that have, again, sort of geometric representation, information representation, and process representation. And I guess I would just say that, things go well on projects when those different kind of constructs are aligned, and things break on projects when there's a misalignment between those different sort of organizational structures. And to me, it's always been sort of interesting to look at the organization of projects in terms of their contracting, their information structures, their physical artifacts, and think about how they connect to each other and how those different sort of topological structures can persist across different representations. So just say that those sort of constructs of organization, associated complexity, those things persist in nature, they persist in the real world, in artificial things, in physical buildings. And it's always been interesting for me to look at sort of physical architectural projects through the lens of this question about complexity and the underlying complexity associated with the organization of those projects. And then the last thing that sort of the takeaway point from that era, I think this is going too long. It's okay. So was the possibility that I started sort of thinking about as these systems started going online, and we weren't just exchanging models and information on FTP sites and on files, but rather what was the possibility of what would happen when the information systems and the information stores associated with a project were continuously available and continuously connected to physical artifacts, buildings, people, those kind of spaces, and what this sort of connected system connected world would look like. And so the idea of sort of devices, scanners, digitizers, robots, PDAs, being connectors between physical and digital, and what you might call a portal that can bind both digital and physical artifacts on a project, started to seem like an interesting possibility for the future. So a lot of that interest has persisted today. Suffice it to say that the company, Gary Technologies, was bought by Trimble in 2014, partly to serve as a kind of consulting and technology connectivity across their portfolio. I got the unique opportunity to take over Chuck Eastman's program in 2016. And this is just a little bit about the organization of the Digital Building Lab. So the DBL is a research program, and it conducts proper research the way I think many of you guys have labs, and I don't want to speak for how you guys are organized, but suffice to say that the Digital Building Lab is much more than my research program. It's a way of connecting to industry and forming bridges from academia to professional practice. So I like to say that that we do our best when we connect industry partners who have technologies, and those technologies can be software or they can be building products, building components, to professionals who have projects and have project needs, and inserting innovation, research, students, interns, all that kind of stuff in the mix. So it's a really interesting kind of dynamic. And I guess I would say, as somebody who has spent a lot of time both in professional practice but also technology development, there is a really critical role for open bodies like academia that neither of those two kind of constituencies can serve. So, so the things that have to happen in places like Georgia Tech that the industry can't solve for itself, and I'll talk a little bit about those things that we're doing. But that's just a bit of an overview about the DBL. In trying to figure out how to talk about all the things that we do, I came up with this kind of 4-component segmentation because, as many of you know, humans can only deal with 4 things. So here are, I guess, between 3 and 7. So, so these are the 4 things we do. A lot of the kind of the heritage of the Digital Building Lab is around data standards and interoperability, open platforms for the exchange of information. My background has been around this idea of project systems, how we take those open paradigms and apply them again in the context of actual, project needs. There's an awful lot of design and construction automation, stuff that we're doing. I think we do more on the automation of the generation of designs, but certainly we're related to folks like Keith Caseman. Is he here? He was certainly here a little bit ago, who's working on the robotic side, and then there's a lot of stuff on the construction side as well. And then most kind of intriguing for me has been this possibility of kind of moving into this idea of smart environments, building systems, infrastructure, and cities. So, okay, so just really quickly, a couple of examples. This is some work that we're doing kind of more on the kind of traditional building system side. I think that should be fairly obvious from, that kind of work should be fairly obvious from the previous discussion. But just this idea of sort of automating the generation of types of building systems and their assemblies. We do quite a bit of work with a gentleman named Russ Gentry, who I don't know if he's here today, around systems including cross-laminated timber. We have a project with Katerra, which is a start. How many of you have heard of Katerra? Okay, right. So heavily investing in a number of sort of the integrated supply chain around a couple of types of building systems. This idea of sort of using, again, timber systems in a structural capacity. At the bottom of this, also one of our PhD students, Mehmet Burmek, is working on sort of understanding how you can do the sort of the structural solution of these systems of kind of kits of parts, how you rapidly translate between the digital representations and the structural simulations at a very different scale. And I don't think this is hugely different than some of the work we saw just in the last session, is looking at the sort of the generation of urban form with the idea of informing the sort of the what we would call the design guidelines for the organization and planning of cities. And I think there's some really interesting possibilities now that we have this scalability of being able to simulate and generate at a high level a city, but then being able to drill into very deep levels of data in order to do very detailed simulations of things like microclimates and heat islands and things like that. A lot of the legacy of the lab is around this idea of data modeling and process modeling that is, again, sort of endemic to the open data standards community. But this is just sort of a view of one of the types of projects that's happening. This is actually a class project from the building building systems and data class, where a student is developing some new constructs in Revit. So how do you, in order to generate the CFD mesh that can then be used to solve for some specific additional components that you can't find in the Revit model, in this case, heat generated and moisture generated by the people in the room, some of the inflows and outflows. So essentially just sort of understanding the kind of the data flow across a particular problem, the data that needs to be represented in that translation, and the sort of the artifacts that result. Okay, so I want to start kind of bridging, using the work of the digital building lab to talk about what I think are three profoundly interesting drivers for the future of practice, and in the Q&A and hopefully in the mixer we'll see what your reaction to this. But these are three interrelated paradigms that I think are going to have tremendous, more than tremendous. I think it's going to profoundly change the building industry, the tools we use, the methodologies, and its relationship to the communities that we serve. So really kind of quickly, so first this idea about cyber-physical systems. Well, I think these are actually all mixed together. So, so just a little bit on the background again. The heritage of the Digital Building Lab has been around these connected information flows and sort of understanding the structure of information that needs to be exchanged, the exchanges, how data is consumed, and the sort of the protocols for moving data around. And over a very long heritage that ended right around the time, or is was largely happened before I got here, there were really dozens of these kind of protocols developed to extend the possibilities for data exchange in the built environment. So Professor Eastman and his students developed exchange methodologies for precast concrete, cast-in-place concrete, steel construction. There's work on the masonry, in the masonry world. Processes for exchange, work that has contributed to the national BIM standard, et cetera. But a lot of that historical work has been sort of about moving data in files. And that creates very discrete transactions where I do something in one piece of software, I save it somewhere, I give it to you, you open it up, it blows up, we go, why don't these things agree with each other? And there's been these disconnects in the data organization and in project delivery that have really sort of stymied a lot of the possibilities for this connected future world. This is a little cheesy, but suffice to say that a lot of the work that we have been focused on in the interoperability community has been focused upstream. It's been tools for ourselves. So, BIM is great for, well, great. It's okay for doing design. It works for engineering. There's a lot of application for it in construction. People are starting to find ways to exchange it and push it into control systems, but it's really not designed for that. And again, it sort of has reinforced a very discrete and disconnected process, ironically. And I think that there's a new world that is emerging that has a very different and sort of profound change in the relationship between, let's call it design, which I would include engineering, hypotheses about the future possibilities of the world, and the experience of that environment. And a lot of this process stuff that we've been very focused on, I think is going to, it's not going to go away, but it's going to be de-emphasized in light of a different relationship between design and experience. And I don't need to really sort of go too much into the details of these definitions with you guys because I think you're aware of them. But this idea of a digital twin is emerging now. Lots that's already sort of polluted in terms of what people think that is. To me, it is about a bi-directional relationship between the physical environment and a simulation or a set of simulations. And that relationship to me has to be bi-directional in terms that we are in the sense that we are getting information from the world into this simulation, and we are pushing intervention back into the world, and that creates this closed loop. There are three kind of cascading definitions that are being bandied around: the digital twin, this idea of cyber-physical systems, and then ultimately this idea of the fourth industrial revolution. How many of you heard the fourth industrial revolution? Everybody? Less so, okay. Yeah, so what binds all of these things together is a couple things. One is this idea of the convergence between physical and digital. Again, through instrumentation, this kind of tight relationship between embedded instrumentation and simulation. This idea of cyber-physical systems, to me, is about the concurrent design of systems that have both information and physical components. And where, as I said, the organization of those, the design of the organization of those systems presumes both an information and a physical component that are very synergistic. And then this idea of the fourth industrial revolution, which is sort of the industrial advances around both that convergence of physical, digital, and also potentially biological systems. So a couple of projects that we've been working on to further those possibilities. I'm bouncing around a little bit here, but this is some work that we've been doing around connecting building information standards to data controls and information coming from building controls and building sensors. So many of you are probably familiar with the data standard called BACnet. That is a data standard that is specifically around streams of information organized through devices and systems. And it has a fairly low-level view of the world, just in terms of things that have sensors, and those sensors have data streams. IFC, I'll talk about. How many of you know IFC? Okay, great, because I'm going to talk a lot about that for the next, I guess, 10 minutes. But IFC is a schema for representing, some of you might think that it's just a crappy way of exchanging information between Revit and structural systems, but it is actually a full schema for the representation of buildings, components, actors, sites, a whole sort of organization of information around the building space. And this is work that we did to sort of develop with Professor Pishdad, who is in building construction, around just saying if we take both of those data standards, port them to something like XML, then we can start looking at very simple linkages between those. So we can start developing these federated sets of information just by moving these things to kind of modern 21st century web technologies and data conventions, and start using the kind of capabilities that are ubiquitous in the world around those kind of, again, 21st century data architectures. So very similarly, there's some great work we've been doing to connect building information models, building energy models, which I'm sure 80% of the people in the audience know better than me, and the building control systems, using, again, things like BACnet and Haystack on one side, and GBXML and some of the solvers, OpenStudio EPC on the other side. This all happens in the context of what at Georgia Tech we think about as the living learning laboratory, which is a sort of a, what do you want to call it, a paradigm that the campus administration has about using the campus as a test bed for new technologies, new data approaches, new ways of looking at the built environment. So these are just some of the apps and data sources that we have available to connect. This is just a couple of examples. You guys were in Cadell. You probably didn't see that, but we have a number of sensors that are kind of the usual thing, kind of homegrown occupancy, temperature, sound, lighting, all that kind of in a Raspberry Pi. That's streaming data from 6 points in the space. I think it's a really interesting space because it is reconfigured. It's a sort of a reconfigurable space that is actually reconfigured. And so we're starting to get data that we can use to sort of map the use of that space to the kind of information that's coming from the environment. Very early work to try to connect that to augmented reality, just to sort of understand what could be the interface of that information as an overlay to experience. I just want to give a shout out to Keith Casement, who's taking that idea about the sort of the connected physical infrastructure of the campus and starting to apply that in the digital fabrication lab, which I assume you guys will all go over to see, in terms of this idea about mixed robotics, sort of spatial positioning, drones, robots, and the interplay of that around physical manufacturing and fabrication. So I think this idea of the kind of the connected campus is happening in a number of ways. I won't spend too much time on this except to say that the campus data platforms are, to me, a microcosm of the open platforms for the industry. And campus IT provides actually a lot of infrastructure that is, adheres to the prevalent kind of utilities that are available in the broader world. And I've gotten quite involved now with Building Smart, which is the organization that maintains IFC and the open data standards for the building industry. They've kind of gotten a bad rap because they've been very focused on some legacy technologies to do this data modeling. But for those of you that are interested, come talk to me later, because I think there's a mini revolution going on there. This is, if anybody's never opened an IFC file, this is what it looks like. If you've ever seen Fortran, I always think that, this looks a lot like Fortran, and it is Fortran era technology. And a lot of people were pretty proud that they could create a description of everything in the built environment using Fortran constructs, but it really has held things back. So I think the opportunity that I'm seeing in working with that organization is coming up with what I think of as the building industry data stack, which will combine at a low level all of the kind of, the basic capabilities that we have from, the information world writ large, devices, communications. We need some help around IoT data standards. This is kind of the domain that the building, IFC, Building Smart, and STEP have been focused on. And then there's some new capabilities on top of that. So suffice it to say that by moving the kind of the conventions of the building description world into modern web services kind of approaches, I think we can come up with a really interesting platform for changing the dynamic of the built environment, not just in terms of exchanges among stakeholders, but also connections to the real world through IoT, and it creates some really interesting possibilities for practice. So I'm going to skip the rest of this except to say that there's some really interesting developments that we're building in terms of coming up with opportunities to support automatic machine translation of building data across a number of different kind of environments. This is some work that a research scientist of mine that works with me, Sinisa Kolarek, has been doing. I saw some better looking stuff an hour ago, but suffice it to say, this uses the Cesium engine, which is kind of an open source Google Earth. And what we're trying to do is create this kind of app store on top of that, which will allow very flexible ability for people to upload new kind of data services apps in a way that I think can create a community around that possibility as well. And I think I want to close with just talking about these new possibilities for practice and entrepreneurship. And again, this has been very much informed by my experiences working with Gary Technologies as a software company in the building space, and sort of the fascination that I've had about these kind of alternative models for delivering innovation into the built environment. And suffice to say that sometimes you actually need a different sort of organization and business model in order to affect the kind of change that is needed for us as professionals and as generators and consumers of innovation in the built environment. So just in the last 3 years, I would say there's been, and again, I don't know what you guys see, but there has been an explosion of interest in the built environment from non-traditional players. And so this is, I think about now 24 months ago, McKinsey, Boston Consulting, all of these kind of management consulting companies all came out and declared this, that construction is the next great sort of tech play. And I think this is really true, that we are at a moment in time when profound disruptive change is available to this industry. I find it very exciting. And just, the explosion of kind of startups, new ways of thinking about the built environment, a lot of really interesting things are happening. So, and again, some of the signals about that, I don't know how much you guys follow this, but the heavy investment by capital, billions and billions of dollars are coming into the built environment through this organization called SoftBank, which is the largest venture capital fund on the planet. And this gentleman, Mr. So, I think his name is, has declared the built environment, healthcare, and I think one other thing as the primary things that he's going after in terms of new types of innovation in the economy writ large. Lots of investment going into companies like WeWork and Katera, as I mentioned. Fascination with these hard problems that are infrastructural problems. So we're not just the tech community is no longer just interested in things like social media and B2B and on B2C and all that kind of stuff. They're coming into the built environment. There's a huge proliferation of startups right now. How many of you are working with kind of a startup? Anybody? Okay, great, good. So this is a moment in time, and I can't imagine 10 years ago if I'd asked that question that anybody would have answered that question. But kind of three different kind of models. First, the kind of traditional venture capital funded startup. There's tons of innovation coming out of just, individual innovators in large organizations. I suspect the honeybee and ladybug people are in this room somewhere, so I shouldn't talk too much about that. But actually, is that true? Okay. But, people who work in traditional firms and just as a hobby are generating technologies which have profound influence on the industry. And then alternative types of organizations. One of them that's really fascinating is this organization called T-Twin from Thornton Thomas Eddy, which is an internal incubator in an engineering firm that is taking some of the intellectual property they're generating and starting little spin-off companies. So all of this stuff is happening. Again, academia is a really interesting place to kind of, if you don't want to do one startup and you just kind of want to motivate an ecosystem of startups, Georgia Tech has, when I got here, it was remarkable how many sort of programs Georgia Tech has to sort of nurture an idea from just an idea that a faculty person or student might have, all the way to business evaluation, seed funding, incubating, all the way through. And what we really need as the built environment innovators is ideas, right? And there are tons of ideas in this group. There are tons of ideas in our student body and in our faculty. And so one of the things that I've been really keyed on is just sort of building the kind of the programs and the awareness of this as a possible sort of career path for MS and PhD students. And so as part of that, we've been doing quite a bit of, in the context of the Digital Building Lab, quite a bit of sort of outreach to the building community, the professional community, the venture capital world, around really these two ideas. One is this idea of entrepreneurship in the building industry. The second, and I don't think I really spent a lot of time on talking about that, but I will in a second, is just this idea about how data in the environment changes the relationship and sort of the opportunities around sort of generating value in the built environment. And I think I'll leave it here, which is just to say that these three big paradigms are very much related. We need the building information stack, what I call the building information superhighway, as a way of creating the opportunities that have existed in the tech world, but for the building space. So entrepreneurialism, I think, needs those kind of technology platforms to be able to flourish. And I think this idea about the cyber-physical environment is creating a profoundly different relationship between the professionals, the information that they generate, and the possibilities for value creation in the built environment. And I think with that, I will close it. So thank you very much for your time.
Hi, I'm Kian Wee from Princeton University. So I've seen that you talk about IFC standards quite a lot, but I don't see any standards for city scale modeling. So is it a deliberate for city scale modeling? So IFC essentially is for building scale. So for city scale, there's essentially a problem where city scale models essentially don't map one-to-one with building scales standards. So I just interested to know, did you deliberately leave it out, or
just there's always more. So I think OpenStreetMap, CityGML, GeoJSON, all those things. I mean, I assume that came up. I know it came up with the work from Syracuse, sort of CityGML. Again, just really quickly, these are all different data standards that have evolved to serve specific constituencies. In the same way that I talked about the relationship to device level standards and to building controls data standards, the same thing applies to going upscale, right? And the fact is that these data, I mean, there's a lot of problems with developing open data standards, and one of them is they tend to grow faster than we can find ways of sort of consuming them, right? So there's some really good stuff. Open Geospatial Consortium, and houses a bunch of them. OGC has a very different relationship to their data standards than Building Smart does, where they sort of every time one comes along, they go, okay, that's good too. And they're less interested in sort of developing the connectivity among those. I shouldn't speak for the people necessarily, but they seem to curate a bunch of sort of different data standards without sort of really worrying about how they connect together. Suffice to say that, and I just was scratching the surface of this, but there are mechanisms that allow us to create kind of meta frameworks for this, for connecting across data standards. And certainly the relationship between cities and buildings is converging, and we're going to need to find ways of translating from one across the other. And if you're interested, we can talk more about that later.
Thanks a lot for this presentation. I want to say that I'm really flattered to be in this room with you and also Professor Charles Hitterman, because I come from the building information background. So I'm working, I'm Alberto Tono, and I work for HOK.
Okay.
So we are really interested right now in a topic also that I was really curious that was not presented about artificial intelligence. Mm-hmm. And my question is how you're gonna see this is gonna be integrated in our practice. Is gonna be coming from a startup company or like Google X, for example, or big company, big player in the software industry that are gonna eat the architecture domain, or it's gonna come from a consortium in an architecture engineering space. So because now how we're gonna share data, I think is gonna be the big part for applied deep learning. So how you're gonna foresee this problem or solutions?
So that's about 6 different topics. Yeah, so first of all, my co-conspirator is Greg Schleusner from HOK. We are now co-directors of, it's a mouthful, but co-directors of the Building Smart International Technical Room, which basically means we sort of get to architect this thing, which is really interesting. And there's a ton of really interesting innovation happening by folks in kind of all walks of life, but certainly people that are in practices themselves. Partly this is a call to arms, because I think that there is the possibility of the Googles and the Amazons just coming in and taking over, right? And I think we're at a unique moment where we are in the driver's seat of this, but if we don't evolve the way we work, we're going to lose. And so I do think it's a significant question. I think, and this is a little bit polemic, but the the idea of the kind of the siloed, I just do design, I just do executive architecture, I'm just a building envelope consultant. I think that's eroding. I don't think that will mean that there are no super top tier specialists that just do one thing. But I mean, HOK, I don't need to tell you. I mean, somebody said that HOK has the world's, maybe it was HOK in the sport division, has the world's top expert in grass and for stadia, right? So you guys have tons of specialists, but you also have this kind of broad platform capability. But HOK is still, I think, just a consultancy, right? So they don't invest in buildings. They don't have a venture fund. Let's just say I think these large organizations have opportunities, but a lot of the innovation will come from small firms. And what I'm really interested in is the sort of the untapped opportunities to capitalize on innovation in firms, because the way we've done it in the past, and Gary, technology has had a little view of an alternative, but basically we tend to innovate off of the profit from hourly consulting fees, right? And when times gets tough, we don't innovate because we can't afford it. And this world of venture-funded innovation, where it doesn't matter a damn if you lose $1 million or $10 million a year, it's all, the dynamics are very different. I mean, you have to see it and feel it to sort of understand the difference there. And it's not the only model. There are many other models, but I think it's an important model for consultancies to understand, because it is very difficult to innovate off of the diminishing profit on hourly consulting, right? It's very difficult to practice on the basis of a business model that is based on hourly consulting. And some of the innovators that I talk to, have different, even if you're doing kind of professional services, there are alternative models for doing that as well. But that's a long way of saying just lots of things are going to happen in the next decade. I mean, I've been doing this for a long time. I've never seen a more exciting time to be doing what we're doing. And we have to be open to these alternative kind of incoming forces, because they're both opportunities but threats also for kind of the traditional business models. Thank you.
Hello, I'm Ramtin Attar from Autodesk Research. Thanks for a great presentation. I go around and talk to a lot of players, and for them, in terms of when they think about their digital strategy and what does that mean to their future, reskilling of the workforce seems to be one of the key criteria. So I don't know if that's a separate building block from the other three that you mentioned, or it's embedded entrepreneurship. Just very curious to get your opinion on this.
I don't have a good answer for that one. I mean, I guess I'll answer it obliquely first in a couple ways. First of all, my motivation about building smart is to bring. There is a world of people outside of the building industry that eat, as they say, eat data for breakfast, right? Know these kind of open, JSON, these new data standards, and none of them have been interested in the building space, right? So again, I think one of the things that, the limitations of these open data standards have been not aggressively going forward and tackling kind of new 21st century open technologies writ large. I guess I would like to believe that when the economic kind of models and the innovation models change, we will not be kind of an island unto ourselves, right? There'll be a flood of people who are going into, again, doing social media right now, that will find the built environment an interesting place to play, right? The market right now, I think on the construction side, maybe on the architectural side, the number one bottleneck to realizing opportunity right now is constraints in labor. That unfortunately I think is going to change in the next 2 to 3 years. And I think again, I mean, part of my mission is to grow the available set of capabilities in places like Georgia Tech and the kind of places that the rest of this community works in.
Thanks again. Forrest Meggers from Princeton. I'm interested in to hear your perspective. I agree completely. We build a lot of sensors in our lab, and we do a lot of visualizations, and we're pulling data from the Princeton campus like crazy. And there's just so many opportunities, as you mentioned, to play and explore. I'm curious what your perception is, or whether you would like to muse upon the challenge of the infrastructure itself, having a lot of inertia in older standards, not just the digital side, but some of the physical problems with, we've just been building air handling units the same way for the last 50 years, and maybe can data or can new digital models help to sort of shake loose some of the ASHRAE standards that are kind of a tight grip on innovation?
Yeah, probably nothing super profound. I think the the evolution from prescriptive standards to performance standards based on simulation is one of the things that, I don't know if you would feel that that's moving quickly or slowly. My colleague Phil Bernstein, who's now at Yale, has a really interesting, well, he has an interesting new idea every 6 months, but I think 6 months ago, he wrote an article for Architectural Record, and it goes something like this. And again, it's back to the kind of the business model. So, right now, again, if I go back to simulation, right? Simulation is something you do during design and design development, and then the possibilities of kind of validating that is really, we don't. It feels like we're getting closer to having those tools, but we don't. That's not part of the cycle, right? So Phil's speculation goes something like this. What if we got compensated on the performance of the building in the future? And we made predictions on performance using simulation, and then we could validate that in the actual performance of the building. And we essentially, sold futures on the possibility, on the performance of buildings in the future, right? So, I don't think that's, by the way, I think, building systems, building air handling isn't moving very fast because air is relatively large, but solar panels, there's tons of stuff that's changing right now. So I do think I think there's a mini revolution in building products that will probably unfold with the rest of this, and the Kateras of the world. Can I say this or not? The Kateras of the world are looking at, building systems, grids, all that kind of stuff too. So I think there's the kind of the subtext of all of this is that things will change when there's a pull from owners and communities. It's not going to change by us getting incrementally, fractionally better as designers or engineers. This data is going to become valuable when it's useful to the end users of the buildings, right? And I think that's the really interesting possibility about this connected world, because we do some interesting stuff that might be horrific to some of your own, but things like smart retail, which is this kind of multi-channel experience, right? How the online experience, the physical experience, all that kind of stuff. That's one of the first kind of big industries that isn't just about sort of building performance, but is actually about kind of community performance or business performance writ large. There are huge possibilities around workplace, right? So people are looking at, the fact that 70% of a building on any day is unoccupied, is that right? So there's tons of stuff on that side. I'm blathering on here. But I don't know. I don't have answers to the proper kind of building environmental systems. It has been a fascination. It was a fascination of Frank Gehry's for a long time. I didn't talk about that, but he had a gig with Skylab, and he wrote about what would happen. We talked a lot about what would happen if building systems had gone through the pace of reduction, kind of minimization that technology has. So in the 70s, both of them occupied a floor, right? Now one of them occupies a floor, and one of them fits on your thumbnail, right? So, but I don't have any good answers for that. I think that'll come from this community.
Okay, we have, no, this is Chevy, I can't, sorry. I was going to end, but I'm not going to tell the general chair we're ending on her.
Better make it good then. Siobhan Rockcastle from the University of Oregon. My question is that we've talked a lot about BIM, building information modeling, building performance, future of that. And I'm wondering, because you mentioned sort of healthcare in buildings at some point that came up in your talk, and I seem to see a lot more emphasis put on human information modeling. So you talked about what if we could look at building performance and predict sort of trends and sort of take a stake in that evolution over time. And how do you feel about instead evaluating human performance in buildings?
Yeah,
and
absolutely.
trying to measure them as an indicator.
Absolutely. Yeah, I mean, so that's starting to be done. So this is another kind of soapbox thing for me, but you know, what I think will happen is that devices that are currently, I mean, so there's lots of healthcare stuff going on like these kind of physical devices and things like that. A lot of that is going to recede into the environment, and you won't even need to be wearing anything, right? So I don't know if that will happen at the kind of human device level, at the kind of thing that you roll around in a hospital, or whether or not it will just recede into the walls. And in some ways, I don't think it really matters because, you know, it's all sort of available to us as an extension of the architectural or the design, you know, design of the environment and experience, right? So I couldn't agree more. Yeah, and I think that idea of sort of human behavior is really sort of, again, that's accessible to us now as designers in a way that, you know, we used to just draw drawings and we'd hand it to somebody, you know, we'd go out on site and complain that things weren't being built the way we wanted, then the owner got the keys and told us to go away, right? And I think that dynamic is going to get blown open, and architects and designers and engineers have this just, you know, it's a whole new landscape, and I don't know where it will lead, but I think it certainly will lead to this question about experience, right? And whatever that means, right? You know, in terms of health, in terms of, you know, again, sort of like, you know, entertainment or fulfillment, or, you know, but that's all available to us, right? So I couldn't agree more.
Thank you.
Okay, well, thank you, Dennis, very much for a very optimistic talk, because everyone is very excited to be in the field that seems to be going in a very exciting times now. So please help me in thanking Dennis.
Thank you.